In today's video, I'm going to show you how to calculate the area between two curves. Okay, so the area between two curves. Okay, the area between curves. So let's consider we have two curves. The first curve is y is equal to x minus 2 the whole square. Okay, and then the other curve is y is equal to x. Okay, these are the two curves that are given. Now, when we draw these curves into xy coordinate, they have the intersection point, and then those two intersection points are the boundaries of the curves, and then they can create an area between the two curves. Okay, the two curves. Now there are two things now we have to know. First, the question can be something like this without given interval, and it could be with a given interval, and it could be with given interval. Now, in this case, no interval is given here. No interval. There is an interval, but no interval is given in this question specifically. So that means you have to find yourself the interval by two techniques. The first one is you can graph these two curves in a graphing calculator, and then you can find the intersection points of the two. Okay, the intersection points of intersection. All right, the intersection points of these two curves, and then you can simply know that what are the two intervals. The second one is you have to solve. So let's start by solving. Okay, let's start by solving. Okay, let's solve this one. Solve this first function. So x minus 2 the whole square means x minus 2 times x minus 2, right? So this is quadratic. Okay, so this will give me what? This will give me in turn um, x square minus 4x plus 4, because x times x is x squared, x times minus 2 is minus 2x, minus 2 times x is minus 2x, minus 2x minus 2x is minus 4x, and then negative 2 times negative 2 is just, you foil this with this one. I hope you know this algebra, and then you foil this and this, and then you'll get x squared minus 4x plus 4. Okay, so the second question is now, I hope you remember your algebra knowledge, lesson. So there are two numbers, m and n, okay, m and n. If m plus n, they will give me negative 4, and then if I multiply m and n, they will give me 4. So in short, I have two numbers, their sum is going to be negative 4, and then their product is going to be 4. So refer your um, algebra lesson if you forget, but the two numbers are x minus 1, x minus 4, because if I foil this one again, it will bring me back to this original equation. So from this one, x is equal to 1 and or x is equal to 4. Okay, x is equal to 1 or x equal to 4. So according to this solution, the interval is known now from 1, 4. Okay, so when I calculate my area between the two curves, I have to use these intervals. Now, the second task is remembering the formula. The area between the two curves is given by the following: the integral of the top function, all right, the top function minus the bottom function, all right? Or this means that simply the integral of uh, the y top minus the y bottom, in short, times dx, right? From a to b, all right? So you have to remember this one. This is very important. So let's go to my problem. A is equal to the integral. The other important point here is you have to identify which one is the bottom and then which one is the top function. That's very important. So that means you need to have a good background of knowing this graph simply by observation, or simply you can draw them in a calculator and then you can see which one is on the top and then which one is at the bottom. So this y is equal to x is simply this kind of graph, straight line graph. And then this is quadratic, x squared minus 4x plus 4 is going to be quadratic. So that's kind of between 1 and 4. So this is 1 and then 4 is here. It's something, I don't know, something like this kind of, okay, something like it's quadratic. So the area is this area we are calculating. This is the area we are calculating, all right? So between 1 and 4. Anyway, the straight line is going to be on the top. The quadratic is at the bottom. So what I can do is now shortly, the top function is x, right? Top function x minus the bottom function is this one. This one is the bottom function. So this is x minus 2 the whole square, all right? The whole square, simply this one dx, okay? Dx from my limit of integration is now, because I solved the interval, from 1 to 4, okay? So this is the very important part of the question, okay? So this is gonna be like this, right? I can now use different techniques. If I want, I can expand it and then use the expanded form, x minus 2 the whole square, because I did it already here. Or I can make it shortly, use substitution, okay, use substitution. So that means, look at this. This is going to be like this. X times dx minus the integral of x minus 2 square dx, okay? So the left one is easy. The left one is easy, all right? But the right one, I have to do something, okay? So let now, let u is equal to the one inside the parenthesis x minus 2. And then du is equal to what? Du is equal to the integral of, I mean, the derivative of x minus 2 is just 1, because the derivative of the constant is 0. The derivative of x is 1. So 1 dx, 1 times dx is just dx, okay? And then from this, I can substitute simply the dx with du. So this will give me like this, right? X dx minus the integral of u square du. All right. So the same thing, I can change this one right here. Sorry, I can change this dx by du, because already I use u substitution, right? U substitution. This is gonna be x du, right? X du. Very good. From this, I think you can proceed. Or okay. The first one, I don't have a problem. I just can leave it. The dx I can leave the dx simply like that. Okay, you can leave it like that. So, but the second one, I can substitute, or I can use u substitution. Okay, I don't need the first one to change. All right, so let's go. This is gonna give me this. All right, so simply the first one is x squared over 2 from 1 to 4, right? X squared over 2 from 1 to 4 minus, all right, this is going to be u cube over 3 plus constant. But my u is x minus 2. So what I can do is this. What I can do is this. What I can do is this. This is going to be x squared over 4 from 1 to 4 minus, okay? So this is x minus 2, right? X minus 2 cubed from what to what? From 1 to 4 again, okay? Because I substitute over 3, in fact, over 3. I don't have to forget over 3. All right. So the remaining part is simply substituting the numbers. So the first is going to be 4 squared over 4 minus 1 square over 4, which is 1 over 4, right? This is just treated separately. This is the first thing. Minus, okay, carefully open the parenthesis. 4 minus 2, you substitute 4 here. 4 minus 2 is going to be 2. 2 cube is 2 times 2 times 2, 8 over 3, right? Because if I plug in 4 in the x here, 4 minus 2 is going to be 2. 2 the power of 3 is 8. 8 over 3. Right. Minus the next time you plug in 2. 1 minus 2 is negative 1, right? Negative 1, because 1 minus 2 is negative 1. Negative 1 cube is still negative 1. So that's going to be negative. All right, this is minus 1 over 3. Remember, okay, I have to plug in 1 in here. The 8 over 3 is for the 4, right? Minus is the upper limit minus the lower limit. So this minus is from the rule, the upper limit minus the lower limit. All right, so the lower limit is 1. You plug in 1. 1 minus 2 is negative 1. Negative 1 cube is negative 1. Negative 1 over 3. This is negative 1 over 3. All right, negative 1 over 3. So this is gonna be like this, okay? So finally, I will get this. This is, let's go to show you the last answer. You can do it by yourself, but let's finish this one. So this is gonna be what? 4 square is 16. 16 over 4 is, this is gonna be 16 over 4, right? 16 over 4. Where did I get this 4? Okay, this 4 is a mistake. Okay, this 4 must be a mistake. This is 2, right? This one is 2, right? This is 2. This one is 2, all right? So 16 over 2 is 8, right? 16 over 2 is 8 minus 1 over 2, all right? This one is this. So minus simply 8 over 3 plus 1 over 3, right? So this is 8 minus 1 over 2 minus 8 over 3 plus 1 over 3, okay? So if you take this one, 3 times this, right, this is going to be 27 over 6, which is equivalent with 9 over 2. So this will be the last answer of our equation, okay? That's going to be the last answer of our equation, all right? So that's going to be the area between the two curves, area between the two curves. Y is equal to x minus 2 the whole square, and then y is equal to x. All right. Now let's find out the volume. Okay, the volume. The area is already there, and then the volume. The volume by rotating. Okay, by rotating the region bounded. The region bounded. The region bounded by the curve. By the curves, y is equal to square root of x minus 3, all right? Y is equal to 0, and then x is equal to 4, okay? This is very important. Sometimes in the problem, they might not give you the diagrams, simply the equation. So you have to know, or you have to develop the skill of drawing the pictures, okay, drawing the graphs. So this is basically, this is radical function. You know that this one is radical function. So the radical function simply by inspection is it looks like this, right? This kind of graph is radical function, right? So x minus 3 means it's going this is 0, the origin is 0, so 1 2 3, this one is 3, right? This is 1 2 3, okay, can call this 3. So I don't know, 4 is next, 5 6 7 8 9 10 11, this will continue, okay, this will continue. So this is y is equal to q x minus 3 under square root. All right, this is very important. So this is the x-axis. Now the idea is when we rotate this one, when we rotate this y is equal to square root of x minus 3, it will create a volume, right? It will create a volume, something like this. Okay, assume this is rotating. It's rotating like this one. Okay, it's rotating. So we are trying to find the volume bounded in the region by y is equal to 0, x is equal to 4. Okay, x equal to 4 means just this one. This is 4. So there is another area here. So we're trying to find this area, this volume. I'm sorry, we're trying to find this volume, this little volume I'm trying to find. Okay, this little volume I'm trying to find. So what I'm gonna do is I have to use the disk method. Okay, the disk method. All right, the disk method. So in the disk method, so this any disk in this given volume, okay, in this given volume has a thickness dx, right? This amount of dx, that's the dx of this one. So for the disk, okay, for the disk, if I have the disk here, right, it has a thickness, So the volume is gonna be the area of the disk, okay, the area of the disk times the delta x, 3 dimension. So the volume is pi r square times dx. Okay, this is the volume. So by integrating this, I can find the volume of the intended region. Okay, intended region. So let's go ahead. So the formula is the volume is equal to the integral from what to what? From 3 to 4, because the x is equal to 4, and then y is equal to square root of x minus 3. So it starts from 3 and then it stops to 4. All right. So this is going to be pi r square dx. Okay, pi r square dx. This is the pi r square is the area, and then the dx is the distance, a little bit thickness. So we can call it width. So this is area times width is going to be the volume of that little given disk. So substitute now, substitute the number. So this will give me now the volume is equal to the integral from 3 to 4, pi, all right, pi, since pi is a constant, I can take out pi outside, r square. Okay, if this is my r, this is my r, because this is the radius. Everywhere you go, that's the radius, that's the radius, that's the radius. The radius is square root of x minus 3. So radius square means square root of x minus 3, right? The whole square, right? And then dx, this is dx, the whole square, right? The whole square. So volume is equal to now, all right? Volume is equal to now what? The square will make that square root sign take off. So that means pi times, avoid that, 3 over 4. This is going to be x minus 3, right? X minus 3 times dx. Now it's becoming very easy and clear. So v is equal to pi times, right, the integral of x dx from 3 to 4 minus the integral of 3 dx from 3 to 4. I split the integrand into two different integrals, okay? So x dx and then minus 3x dx. And then, in fact, there is pi here because that pi is for both of them. All right, so I can also rewrite this one simply, just pi, take pi outside, all right? Take pi outside. And then this is gonna be the integral of x dx from 3 to 4 minus the integral of 3 times dx from 3 to 4, right? From 3 to 4, right? So this is simply, finally, pi outside, all right? The volume is equal to pi outside into this one, open parenthesis. So x dx means x square over 2, right? This is, I'm doing this one, over 2 from where to where? From 3 to 4 minus 3 times the integral of dx is just x from 3 to 4, okay? So if I calculate this one carefully, this is simply pi times 1 over 2, okay? This is equal to simply pi over 2. The volume is pi over 2, all right? So this is an example of calculating the volume of a solid by rotating a given function, okay, bounded by that curve. Okay, when we rotate that curve, it creates its own volume, and then calculating that volume. So thank you guys for listening and practicing. I will see you another time with another